All right, in exercise 5.4.11, it says a certain population of mussels, 80% of the individuals are infected with an intestinal parasite, okay? 80% have a parasite. Now what we are going to do is we are going to select 100 randomly chosen mussels. Okay, and we want to know what's the probability that 85% or more will be infected, okay? Okay, so if we were going to answer this manually, we would have to do, what's the probability that x is equal to 85 plus probability that x is equal to 86, all the way up to having the probability that all 100 are infected. And this would be 100 choose 85, 0.8 to the 85 times 0.2 to the 15, plus 100 choose 86 times 0.8 to the 86 times 0.2 to the 14, so on and so forth, all the way up to 100 choose 100, yada yada yada, 0.8 to the 100, okay, 0.2 to the 0. This would be very tedious for us to do. We could do it on the computer, and we would just do p by no. Okay, and we would actually, p by nom gives us 0 through that number, so we would do p by nom 84, p equal to 0.8, n equal to 100, and this would give us the probability of 0 through 84, and we would subtract this from 1, and this would give us the probability of 85 to 100. But what we are going to do is we're going to answer this using the normal approximation. Okay, and so our normal approximation, we've got to figure out the mean and the standard deviation. So our mean is going to be n times p, or in this case 100 times 0.80, which gives us a mean of 80. And our standard deviation is going to be the square root of n times p times 1 minus p, which is going to be the square root of 80 times 0.2, square root of 16. My standard deviation is 4. Okay? And so now I've got a normal model with mean 80 and standard deviation equal to 4. And I want to know what's the probability of having 85 or more. Alright, so in this question, we have to use a continuity correction. So let me erase this stuff up here, which we don't need anymore. And we're going to figure out what we want to draw. So if we draw the curve like this, we are centered at 80. Okay, and as we go out, we want to see if so here's 81, 82, and I'm drawing these too fat, but 83, 84, 85. But here, let's just pretend like there's other bars here, and if we want to include 85 or more, we want to include 85 and all of these future bars, we want to include that bar. Our cutoff is going to be at 84.5 because we're looking at the probability that 85% or more, we're looking for 85 or more mussels having the parasite. Okay, so our cutoff is going to be 84.5, and that's the continuity correction, is 84.5. So at this point, we figure out our z-score. Our z-score is going to be 84.5 minus 80, divided by our standard deviation of 4. So we have 4.5 over 4, which gives me a z-score of 1.125. So I'm going to round off to 1.13, and then I want to know what's the probability of being greater than 1.13. So I can look up positive z equal to 1.13 and subtract that quantity from 1, or I could just look up z equal to negative 1.13, and that will give me the quantity that is greater than positive 1.13. So anyway, however you look at it, the probability that z is greater than 1.13 is equal to 0.1292. And that is it for 5.4.11.